Comparative study of story displacement and stiffness under different seismic zones for RC structure. Abstract structural developments are increasing rapidly nowadays throughout the world. Natural calamities like earthquake are happening frequently around the world, hence, the structure has to be designed for the same. The critical seismic analysis of reinforced concrete building, specifically involves the understanding behavior of structure under lateral loads unlike the usual gravity loads such as dead loads and the live loads. In order to design an earthquake-resistant structure, the analysis of the structure G+9 story is done using ETABS 2013. G+9 story is analyzed for different types of seismic zones and soil types as per IS 1893:2016. Further, the behavior of the structure is studied for the parameters such as natural period, displacement, base shear, and story stiffness. Keywords: seismic zoning, soil types, natural period, displacement, base shear, story stiffness. Introduction. Natural calamities like earthquakes are the most dangerous by means of the damage to the structural components, and they cannot be predicted and controlled due to sudden occurrence. But attempt can be made to minimize the vulnerable seismic effects. Seismic waves travel through Earth's layers. As a result, shaking of Earth's surface leads to damage of structure. Also, these lateral loads can develop high stress, produce sway movements or cause vibration. Therefore, it is very important for the structure to have sufficient strength with adequate stiffness to resist lateral forces. The existing buildings are vulnerable to earthquake, so the importance has been given for earthquake resistant of building. The analysis of structure for the seismic resistance involves the understanding the behavior of the structure under lateral loads and normal loads. In this study, structural analysis of building based on the seismic zones of the area and the types of soils is carried out. The seismic zones are 2, 3, 4, and V. Among these, Zone V is the high active region and Zone 2 is the low active region in India. The behavior of structure under various seismic zones and soil types has been studied. 2. Methodology. A. Details of structure and analysis. The analysis of G+9 RC structure is carried out. Seismic analysis according to IS 1893, Part 1 2016. Analysis is carried out for structure in Zone 2, 3, 4, and V. Effects of earthquake loads applied on the structures are studied in 2 methods, namely A. Equivalent static method. B. Dynamic analysis method. B. Modeling. The model is analyzed in ETABS 2013 by the following steps. 1. Material properties such as grade of concrete, grade of steel is defined. 2. Section properties are assigned as beam, column, slab. 3. The columns are restrained at base level. 4. The loads are applied onto the structural members. 5. Different load cases and combinations are carried out. 6. Function is assigned based on seismic parameters considered for analysis of structure. 4. Results and discussion. The models are analyzed for equivalent static force method. Results of the models for different seismic zones and soil types are discussed below. A. Natural period for all the models. 1. The natural period for Model 6 is the least with comparing to other models. 2. The natural period for Models 11 and 12 are the highest with comparing to other models, as they are under seismic zone V. They are almost 1.5 times greater than the least model value. 3. From the graph 1, it is observed that Model 4, 5, and 6 shows the least affected by the seismic forces, which lies in seismic zone 3. B. Displacements for all the models. The displacement comparison is done on the basis of different seismic zones. From the graph 2, it is observed that Model 3 has the highest displacement, which is 1.67 times higher than the Model 1 and 0.81 times higher than Model 2. This is due to the Model 3 is present in soft soil. From the graph 3, it is observed that Model 5 and 6 has the highest displacement and almost same, and both are 1.36 times higher than the Model 4. The displacement is less in Model 4 as it lies in hard soil. From the graph 4, it is observed that Model 9 has the highest displacement, which is 1.67 times higher than the Model 7 and 1.22 times higher than Model 8. This is due to the Model 9 is present in soft soil. From the graph 5, it is observed that Model 12 has the highest displacement, which is 1.67 times higher than the Model 10 and 1.23 times higher than Model 11. This is due to the Model 12 is present in soft soil. Referring to the graph 2, 4, and 5, the behavior of structure is similar in soil types I, 2 and 3. The soil type 3 shows the higher displacement of the structure. Referring to graph 3, the behavior of the structure is similar in soil types 2 and 3. The soil type I shows the least displacement of the structure. See stiffness of all the models. The stiffness comparison is done on the basis of different seismic zones. From the graph 6, it is observed that all models behave similar. From the graph 7, it is observed that all models behave similar for story 2 to 10. The variation is observed for the story 1 in the model 6 having least stiffness. From the graph 8, it is observed that all models behave similar. From the graph 9, it is observed that all models behave similar. In story 2 has least stiffness, which could affect the structure. Conclusions. 1. From table 1, it is seen that the natural period is the least for model 6 being in seismic zone 3. 2. Natural period is higher for the model 8, 9, 10, 11 and 12 having seismic zone 4 and V. They are having almost 1.5 times more than the models under seismic zone 2 and 3. 3. From graph 1 and table 1, it is observed that the natural period is more in case of models under soft soils. 4. From graph 2, 3, 4, 5, it is observed that the displacement is having similar behavior in all stories in all models. 5. From displacements comparison, it is observed that the displacements are higher for models under soft soils. 6. Displacements are higher on the upper stories, due to the effects of different seismic zones and soil types. 7. Displacements for models with soil type 3 are almost 1.67 times higher than that of models with soil type I. 8. From graph 6, 7, 8, 9 it is observed that the stiffness is higher in lower stories and for the models under soil type I. 9. From story stiffness comparison tables, it is observed to have least story stiffness in second story for the models with seismic zone 4 and V and soil type 2. 10. From the study it is observed that for models with seismic zone 2 are the least affected with the seismic forces as compared to the other models.